All right, we're ready here for our last, well, second to last example. Here's number 4. Here's the picture. So there's a right triangle. We're going to draw an altitude from that right angle. And let's say this is X, Y, Z. The altitude is 4, and this part is 8. When you look at this, you don't necessarily go in order X, Y, Z. So you have to kind of figure out, what can we find, what do we not know yet? If I look at, we do have the altitude. That's nice. I always like altitude squared as part times part. Now the two parts are X and 8. We do know the altitude, so actually we can do altitude squared equals part times part. So 4 squared equals part X times the other part, which is 8. So we have 16 equals 8X. Oh, just divide to undo that multiplication. X is equal to 2. All right, that's nice. Now, if X is 2 and the other part is 8, then that means that the whole thing here is 10, if we need that. Y and Z are legs. So let's do leg squared equals adjacent part times the whole. The way that I remember these formulas is by writing them down. That's how I memorize. If we want the Y, so Y is the leg, Y squared equals. Now the part that is adjacent to Y, that's the 2, times the whole hypotenuse, that was 10. And we get Y squared equals 20. Now the square root of 20, think of a perfect square factor that goes into 20, that divides into it, 4. So 4 times 5, 4 is perfect. We can take the square root of that. We get Y equals 2 times the square root of 5. There's your Y. And lastly, we'll do Z, which is another leg. Z squared equals the adjacent part now next to Z is 8 times the whole hypotenuse is 10. That is 80. Take the square root of both sides. Now let's see, 80 is divisible by 4, but it's also divisible by 16. That's a bigger perfect square. I'm going to do that. 16 times 5. 16 is perfect. We'll take the square root of that, and we get Z equals 4 times the square root of 5. Now, that was the last example, but I want to show you one more thing here. And to do that, I'm going to go back to our original picture. A, B, C. Here was D. Opposite angle A, this is little a. Opposite angle B, this is little b. Those are the lengths. Now opposite angle C, the whole hypotenuse, is little c. And I'm going to call the other two parts E and F. Okay, here's the altitude. Here's a leg, and here's the whole hypotenuse. If we did leg squared equals the adjacent part times the whole hypotenuse. If we did that for A, in this, A is a leg, little a squared equals the adjacent part, that's F, times the whole hypotenuse, which is C. Okay. What if we did that for the other leg, B squared? That would be the adjacent part, which is E, times the whole hypotenuse, which is C. If we add those two equations together, we get A squared plus B squared equals, now that is, I'm going to write that as FC plus EC. Now, on that right side, one thing we can do, since both of these have a c, I'm going to factor out the c. I'm going to pull that out of the parentheses, and what would be left is f plus e. Now, if you look in the picture here, well, e and f, if you add those, doesn't that give you the whole hypotenuse? E plus f is equal to c. So I am going to substitute f plus e is the same thing as c. And then there's one more thing here. A squared plus b squared equals c times c, which is c squared. What we have just proved is the Pythagorean theorem. That in this right triangle, the big one, a squared plus b squared is equal to c squared. This is a proof of the Pythagorean theorem. We have proven that this must be true in all of those situations. For any right triangle, a squared plus b squared is equal to c squared. So when you use this formula, you could even use it back in this section. The only reason you're allowed to use it is because it must be true, and it must be true because we just proved it to be true using the geometric mean. Now, there are more ways to prove Pythagorean theorem, but this is one of them. And that's the end of the notes.